Hello, my name is Dave Farnia, and in today's webinar, we're going to see how we can quickly create an efficiency map using JMAG. In today's webinar, we'll start with a brief overview, and then we'll get into creating an efficiency map using the JMAG-RT Viewer tool. We'll see how it's done, learn about the benefits, actually see how JMAG-RT Viewer works, learn about the functions in RT Viewer, and check out the required licenses. Then, we'll look at generating a torque speed curve using JMAG-RT Viewer. We'll see how that's done, and we'll learn how to request a license. Finally, we'll conclude with a short summary. JMAG-RT Viewer enables you to create an efficiency map in a few short steps. This webinar demonstrates the basic operation of JMAG-RT Viewer. Let's start with what is a motor efficiency map. Well, it's one of the performance indicators necessary in evaluating a motor. It allows you to confirm the efficiency over the operating range. Typically, in order to generate an efficiency map, we would take a motor and hook it up to a dynamometer. We'd have our control circuitry going in and measure the power that the control circuit is applying to the motor, as well as a torque transducer and a speed transducer measuring the power output from the motor. We use the power in and the power out to calculate the efficiency at every operating point within that efficiency range. The number of operating points measured is a function of how accurate we want the efficiency map to be. In this case, for this efficiency map, if we look at 5,000 RPM and about 10 Newton meters, we see that the efficiency is approximately 85%. The challenges to obtaining efficiency map are that the excitation parameters need to be precisely controlled as the motor is going through its operating range. Thus, we need to control the current amplitude and phase to maximize the efficiency across the entire operating range. Finding the maximum efficiency at each operating point requires a great deal of effort, as well as measuring the input and output power accurately. JMAG-RT Viewer can simplify this process. So let's see how JMAG-RT Viewer can generate an efficiency map. The process in JMAG is to start with preparing a motor model. Then take this motor model into JMAG-RT Viewer and configure the settings for the inverter and the control type. Then, in JMAG-RT Viewer, we click on the Efficiency Map button and generate the efficiency map. This all seems very easy right now, but I'm sure you have some questions going through your mind. Perhaps, how do I generate a motor model? Or, how do I set the inverter rating? Or even, how is the highest efficiency point calculated in JMAG? Well, over the next few slides, we'll answer some of these questions and demonstrate how JMAG can be used to create an efficiency map. But first, let's talk a little bit about the benefits of using JMAG. First, there's no physical testing required. You design the motor, simulate the results, find a motor that approximately meets the minimum threshold that you want, and then convert that motor simulation into a format suitable for generating an efficiency map. In JMAG, that format is the JMAG-RT model block. This model block represents the motor performance and can be dropped into the JMAG-RT Viewer. Once that model block is in JMAG-RT Viewer, we set the inverter ratings and the control type, click the efficiency button, and generate the efficiency map. So at this point, it's just a matter of dragging over your motor model, setting a few values, and clicking a button. So we see it is fairly easy to do. Another benefit is that we can test various control topologies within JMAG-RT Viewer and determine how they affect the efficiency of the machine across this entire operating range. The types of controls that we can use are ID equals 0 control, which controls the D-axis current to be 0, maximum torque per amp control, maximum torque per flux control, maximum efficiency control, moment of force equals 1 control, flux weakening control, and finally maximum output control, which combines the above-mentioned method and drives the machine so that the output achieves the maximum value over the entire operating range. Another benefit is that we can automatically set motor temperature independently, so we can choose the temperature that the magnets are operating at, as well as the temperature that the coil is operating at. For magnets, an increase in temperature leads to thermal demagnetization. So we can see that the magnet properties at room temperature are much higher than the magnet properties at higher temperatures. As far as the coil goes, increasing the temperature increases the resistance of the coil. If we compare an efficiency map generated for a machine at room temperature to an efficiency map generated at elevated temperatures, we can see that there is a reduction in efficiency. So how does JMAG-RT Viewer work? Well, first we need the motor model. A motor model refers to a high-fidelity 1D model using a JMAG-RT model that is created using JMAG. So in this case, we can see that we have our simulated model, and then we generate our JMAG-RT model. That JMAG-RT model block contains numerical data for torque, inductance, resistance, and iron loss at each operating point in our operating range. How can I obtain that motor model data? There are several methods to obtain this data. First is JMAG Express. This is the simplest way to obtain the data, but we have the least amount of control over the operating range that we're working within. So in JMAG Express, you push a button and automatically generate an RT model, but we don't have a lot of flexibility when we're setting the operating range that we want to evaluate. We can also use JMAG Designer. With JMAG Designer, we have much more control over setting the operating points that we want to test the model at, as well as the level of fidelity in the mesh or time step, etc. But the drawback is now we have to know how to set up those parameters and set up that model. We can also use actual measurement data saved as a CSV file. So if we have our motor on a dynamometer already, we can pull out values and then apply them to an RT model block and then use that RT block in creating our efficiency map. The final option is to use the online motor library, which has a large section of motors with various outputs. The benefit of an RT model is that it is a separate block and only contains numerical information that captures motor performance. That is, the RT block is completely separate of our actual FEA analysis, so it only has numerical data. This allows for very high-speed calculations since we're only using the data in standard formula. The models are also high fidelity since they are based on actual simulation results, not just formula. So again, instead of just having a linear reaction, we can actually capture nonlinear results, such as the drop in inductance with an increase in current, or the drop in inductance as saturation increases. The other factor is that the iron loss simulation results are also captured, so we can more accurately capture the iron loss data to get a better idea of efficiency across that operating range. All this information is what's going to be captured in that JMAG-RT model block. So, when we go in, we've looked at what kind of control types we have, but we also have to set the inverter settings. So what do we mean by maximum voltage and maximum current? Well, the maximum voltage is equivalent to the DC bus voltage supplied to the inverter. Assuming that the motor's line voltage is V sub A, the motor can be operated within the range indicated below, where V sub A, or V phase, is less than or equal to the maximum voltage divided by the square root of 2. Maximum current refers to the current in each phase of the inverter and is usually determined depending on the power electronic component rating. Assuming that the maximum value of the motor's phase current is IPH or I sub PH, the motor can be operated within the range indicated below, or I phase is less than or equal to I max. As far as the control types that we have, most of them are self-explanatory, but the last one, the maximum output control, might need a little bit more explanation. In this control method, it's going to maximize the torque at each rotational speed within a range of inverter's voltage supply abilities. The borderlines are determined with the maximum output conditions, and the inner range is determined through the maximum efficiency conditions. This first voltage boundary is set by the inverter voltage, so the inverter voltage supply is sufficient in this part, and it reaches the upper current limit. As the voltage starts to fall short, the borderline is going to be determined based on either field weakening control or maximum torque or maximum flux per amp control. So we can see that we're going to get the furthest envelope possible using a variety of control strategies. Within this operating range, we're just going to try to maximize the efficiency at those operating points. Another control method is the ID equals 0 control method. The borderline is determined based on that ID equals 0 control method, and the inner range is calculated with the maximum efficiency conditions. However, we can see that the voltage is insufficient with ID equals 0 control to go past a certain point. So instead of getting a maximum operating threshold, we can see that the ID equals 0 control is fit within a very certain range. About the motor efficiency map generation capabilities, we can do 3-phase PM synchronous machines, induction machines in the very near future, and switch reluctance machines currently. Items that can be considered are the iron losses in the machine and the copper losses or I²R losses. Items that cannot be taken into consideration are the mechanical losses, inverter losses, phenomena such as eddy currents in the magnets, effects from slot harmonics, and effects from PWM carrier harmonics. So again, some of the inverter effects and mechanical effects aren't going to be captured, but the majority of the losses are captured in the iron loss and the copper losses. Some of the additional functions of the JMAG-RT Viewer are that we can save the conditions that were used in the RT Viewer or in the efficiency map creation process. And we can reuse these settings on different models. The setting files can be output in XML format and then again applied to different models, so the inverter rating and the control type, as well as any correction coefficients or temperature correction coefficients, can be applied to different models. Now, I just mentioned correction coefficients, and that's something that we also have the capability to do in JMAG-RT Viewer. We can put in correction coefficients for the inductance, the flux linkage, and the iron losses, as well as correction coefficients and actual temperature characteristics for the coil and the magnet. So again, we can either choose to operate at room temperature, a reduced temperature, or an elevated temperature for both the coil and the magnet. Besides being able to render an efficiency map, we're also able to render an iron loss map across the operating range, a copper loss map, an iron loss plus a copper loss map, a D-axis current map, a Q-axis current map, a phase current map, a D-axis inductance, and a Q-axis inductance map. So as you can see, instead of just looking at the efficiency, we can see what happens to the iron losses across the operating range, or the copper losses across the operating range. So we can get a much better idea of how the system is actually performing and ways to reduce the losses or increase the efficiency at desired operating points. Another feature in JMAG-RT Viewer is that we can save the efficiency maps and we can output them in various formats. We can output the map as a PDF file for generating reports or an image file. We can also export the digital data as a CSV, so again, get the numerical point data in those operating ranges, and then generate an efficiency map in a program such as Microsoft's Excel. So at this point, we'll pause the presentation and we'll go over and look at how we can generate an efficiency map in JMAG-RT Viewer. So I've moved over to JMAG Express in order to create a basic RT model block. JMAG Express is the fastest way within JMAG to generate motor results. If we look at that brushless motor IPM model, and in this case I'll just go to the first model that's available, which is the PM_I_D_I, and I'll open up that model, and in this case I won't change or modify any of the settings for the dimensions, the materials, the winding, or the drive, so I'll just leave everything as its default value. If I click on the light bulb, within a couple seconds I'll be able to generate some basic operating parameters for this machine. I can see the torque and efficiency versus the current amplitude, the copper and iron losses versus current amplitude, the DC bus voltage or approximate DC bus voltage versus the current amplitude, the D and Q axis inductance, torque constant, rated current, and average tooth flux density. So I get a lot of basic information for this machine. Again, JMAG Express is using what I would consider a hybrid FEA approach that's a combination of a lumped parameter model as well as some basic FEA analyses. So besides being able to get some basic output parameters, I can also generate a JMAG-RT model block. In order to do that, I click on this RTT, and it's going to ask for an output directory. I'll set that to the desktop, and then I'll choose the type. When we're generating an RTT file, the type isn't going to make a big difference. So I'll leave it right now on the Simulink electric signal output, although we could use either a current signal, a voltage signal, a PSIM model, or a LabVIEW model, and the RTT file associated with each would be approximately the same. So I'll leave the Simulink electric signal input, and I'll just create a file name. I click OK, and it's going to ask me, I already have some DLL files for the RTT on my desktop, and it'll just ask me if I want to overwrite those. At this point, yes, it is fine to overwrite any of those DLL files. And you can see within a few seconds, we're going to be able to generate a JMAG-RT model block. So as I mentioned in our presentation, the only drawback is it's very basic. It's a simple constant parameter DQ inductance, and will have some information on the operating range, but not a whole lot of information on the operating range. If I want to go in and create a higher fidelity RT model block for looking at the efficiency map, I'd have to move into JMAG Designer and use our RT creation tool. So if I click on this JMAG button, what it'll do is it'll ask me to export the model as a JCF file and then open it in JMAG Designer. So I'll open that JMAG Designer model, and I've already made one modification to this, which was to add the iron loss calculation. So the model itself has been completely set up in JMAG Express and exported into JMAG Designer, where I can, again, do a more comprehensive analysis, change the mesh settings, change some of the attributes of the machine, such as the rotation speed, the number of turns, any of the parameters that I want to investigate. I can make modifications and treat this as a completely independent FEA model. So now that I've added the iron loss calculation, again, we'll be able to, capture the iron losses in our RT model block. At this point, I would go and I would just export the mesh data for this model, and then go to our JMAG-RT model tool, and then set up the RT model block using our RT tool. So when I open JMAG-RT, I'm going to create a new model, and I'm going to be able to choose the type of model that I want to work with. Whether it be a 3-phase PM synchronous machine, 2-phase stepping motor, linear solenoid, linear synchronous motor, switch reluctance machine, or induction motor, I can create RT model blocks for any of those machine types. The efficiency map tool, however, only works for the 3-phase PM synchronous machine, the switch reluctance machine, and very shortly the induction motor. So that's the only drawback between the RT blocks that we can create and the JMAG-RT Viewer. So I'm going to choose the 3-phase PM synchronous machine and click OK. Now it's going to ask me for the level of fidelity that I want in my RT model block. So I have my basic DQ model, which is for system level design, and breaks the machine model into its D and Q axis components. So when I do this, my D and Q axis inductance are dependent on current and phase advance angle, but slot harmonics are not taken into consideration. My spatial harmonic model, on the other hand, has inductance and torque dependent on the current and phase advance angle. Slot harmonics are included. However, in the case of high saturation, sometimes the inductance might not be accurate. When we export the model from JMAG Express, it's a basic DQ model with a fixed value LD and LQ. If I go through JMAG Designer and then use the JMAG-RT tool to create our RT block, I can get a higher level DQ model or that spatial harmonic model. But for now, what I'll do is I'll just do a higher fidelity DQ model. I'll browse, and I'll find that file on my desktop and click OK. Now, an information screen opens up, and I can change my title and add information about the machine to my JMAG-RT model block. I can also publish motor information and resolution. So I'll do that right now. And I'll go to Create. And in my motor model, I have my DQ model, and it's going to ask for the configuration of my coils. That is already set correctly. And I'll change my number of turns and my phase resistance. And again, if I go back to my JMAG Express model, you can see that in the winding, I can make those values match my JMAG Express model. So it's 0.814 ohms. Now, in my DQ current settings, I can use an advanced setting procedure to apply more current amplitudes. So let's say 0.5 amps, 1 amp, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5 amps. So if I go back to my express model, our drive was 3 amps and up to 3000 RPM. But now my model has a little bit higher fidelity and captures more currents. As far as my phase angle goes, I'll also add more points for my phase angle. And I'll assume that this is mostly motoring, so at this point I won't go through and create a lot of different phase angles for generating or multiple quadrant operation. I'll just assume my operation is going to be in the first quadrant between 0 and 30 degree phase angle. Click OK, and I'm actually going to allow the iron losses, and I'm going to set my maximum revolution speed. So instead of 3000, I'll go up to 5000 RPM. So now we can see the number of calculation cases. So again, we're going to get a much higher fidelity than our basic express model, and just due to the increase in the number of points that we're evaluating. So at this point, I click OK, and what's going to happen is JMAG, it's going to come out in my RT block, and I can go to Create Model. And now, what's going to happen is it's going to go through and start crunching the numbers. So at this point, the model runs, and we can see that we get through the analysis and we have no warnings and a few messages, but effectively that RT model block has been created. So now what we would do is close this down and then click Copy to Control Circuit Simulator and export the RTT file. So we'll put this back in our desktop as well. And instead of test IPM, I'll call it test IPM V2. And we click OK to export that RTT file. So now we have two RT model blocks. We have the initial one that was created with JMAG Express that is based on a very simple model, and we have the more comprehensive one that was created using the JMAG-RT tool based on a JMAG designer model. So let's open up JMAG-RT Viewer and take a look at the two. So in the first one, I'm going to open that IPM test 1, that's our express-based model, and we can see that this RTT file contains constant values for LD and LQ, so the inductance map function is not available. But if I click on More, I can now see that I'll get my efficiency map capabilities. So we can set our max voltage for our inverter, and our max current, and our max inverter voltage. If we go back to Express, we can see that at 3 amps, so maybe about 280 volts, let's say. So we'll change that to 280 volts, and we'll generate max power, and we'll go to the rated speed of 3000 RPM. So if I click on the efficiency map feature, it says that out of range calculation data in the RTT file, so the accuracy of the calculation may be reduced. This is because of the phase angle. I don't have a lot of phase angle data available. So in my RT block that I set from JMAG Designer, you'll notice that I had set the phase angle. Now with this data, I did not. But we can generate our efficiency map, and it allows us to take a look at things like the operating range, or the percent of the operating range above 90%. And we can also look at such things as changing the display from efficiency to iron loss map, copper loss, copper and iron loss, speed versus ID, speed versus IQ, phase current, LD, and again, we have constant parameters, so there's a little bit of extrapolation here, but basically we're kind of stuck with the LD and the LQ. Click Close, and I'll close this down, and I'll go back and I'll open up a different RT Viewer, And now we'll open the model block that was created from JMAG Designer, that test IPM v2. So now you can see that in our motor info, we actually have phase resolution. You can see the phase angles that I used, and the inductance current resolution. You can see the currents that I used. So now we actually have a D-axis inductance map and a Q-axis inductance map. And both of these maps are the actual D and Q-axis inductance versus the phase angle and the current. So now if I go to more, let's set those same inverter properties up to 3000 RPM. And again, I won't change any of these correction coefficients. So inductance is 1, flux is 1, iron loss is 1. Temperature correction will, for the magnet and the coil, will leave at room temperature. And click on the inductance map feature. And what we should find is that the data should be fairly similar. So we don't get, we're operating in a very nice rated range. We're not going into heavy saturation. So the performances should be fairly similar. But we'll notice that the efficiency map is going to take a little bit longer to produce since, again, we have more data to draw upon. So we can actually alter the operating point and then change our phase angle, change the current resolution, so we can get a little bit more accurate data and description for this efficiency map. And what we find is that, for the most part, results should be fairly similar. So a majority is above 63.9%. And what we'll do is maybe I'll leave this on the right side, the left side of the screen, and I'll go back and I'll generate over here. I'll go back and I'll regenerate our map for the express-based model. So I'll go from 280, 3 amps, 3000 RPM, and I'll generate that efficiency map, and we can compare the data. And what we should see is they should be fairly similar. So looks-wise, you can see, again, fairly similar, but we do see differences. So the efficiency of our higher fidelity model, we show a lower efficiency range, above 90%. At our lower fidelity model, it looks like more of the model is operating at a higher efficiency. So we see some differences now that we go to a higher fidelity. And so that's what we have to keep in mind. If we're getting a basic understanding of our machine, this lower fidelity model should be good. But once we have a need for these higher fidelity models, we can't just use a very basic fixed LD and LQ model. We have to go to a more dynamic model that is capable in our JMAG-RT creation tool. So I'll close the basic one down, and I'll close our inductance map down. And so again, now we have some functionality where if we wanted to save our settings, we can apply them to different machines. And we can open those settings and apply those as well. We can go in and we can adjust our control type to max torque per current, max torque per flux, max efficiency, etc. And we can see how that motor is going to perform. So again, with our RT block, the initial level that's coming off of JMAG Express is good to get a basic understanding of machine performance, but we have to move to this higher fidelity model in order to get a truer understanding of machine performance. One of the other features, and before we get back into the presentation, I'll mention that we do have the capability to do the speed torque curve. So the speed torque curve is just going to draw on the same data, and instead of mapping out the efficiency at every operating point, all we're going to do is look for that envelope of speed versus torque. So it's effectively the same mapping function that we saw before without generating the efficiency maps in between. We'll wait a couple seconds here and look at that speed torque curve, and you can see again it's effectively just the same outside envelope or operating envelope that we saw with our efficiency map. So maybe for a more interesting model, let's look at our speed versus torque curve up to 30,000 RPM. And now we should see that the motor, the voltage that we've chosen, or the inverter rating that we've chosen, isn't going to be enough. So we have to do a little bit of field weakening in order to get the torque out to that speed. So we'll give it a couple seconds here and we'll take a look at what that torque speed curve looks like. So it's out of range for the data, so the max speed is too high. But again, we knew that we were going to set it to a higher value. But now you can see that we're getting our torque up to the point where the inverter doesn't have enough voltage to cover it, and then it's going to start to go into a field weakening operation, and you can see that it's going to generate torque as far out as the inverter is going to let it go. So again, torque speed curve is effectively just an extension of the efficiency map that we're just plotting the envelope of operation without charting the efficiencies inside. So now, moving back to our presentation, let's take a look at the required licenses for this operation. So to render an efficiency map, JMAG-RT Viewers requires a special license. If you have a license for efficiency maps, you also have the ability to render the torque speed curves. If you want to create a custom motor model, that JMAG-RT license is necessary. To generate the inductance map, basically we have to have the RT model tool. Torque speed curve, it can be generated off of any RT block. An efficiency map needs a special license. So a license is required for all of these. But in this case, or for this basic level, this is a free license, and this is a license that is requested. This is the only license that is going to require a purchase. So now if we actually look at that rendering a torque speed curve using JMAG-RT Viewer, we can see that we can do that pretty quickly. We can actually request a free license of JMAG Express Public, which is a simple version of what we were working with the JMAG Express to generate that RT block. And then we can use our JMAG-RT Viewer, and that free license again can cover rendering an inductance map of and torque speed curve and confirming the basic specifications of the JMAG-RT model block. So we can start in JMAG Express, generate that RT model block, and then look at the torque speed curve and the basic specifications. If we generate an RT block from other sources or use the online library or existing data, then we can go in and actually set up different DQ inductances and render an inductance map. So in creating a motor model, again, JMAG Public is a free license. So we set up the model and then we click the Solve button, and again, same parameters that we had seen before. And then we generate that RT model block. So the torque speed curve in JMAG-RT Viewer can be done for free. So obtaining a free license, the installer can be downloaded, and you can apply for the license key on the JMAG International website and download the software and then write in and apply for the license, and you can get JMAG Express Public and the free version of JMAG-RT Viewer. In this seminar, we saw how easy it is to use JMAG-RT Viewer's efficiency map functionality tools. Basic versions of JMAG-RT are available for free, and it's also possible to evaluate any of these JMAG products that we've seen here. If you have questions or comments, feel free to contact us at any one of these addresses. Be sure to tune in next week for our next webinar.